Welcome back. Today we're going to be taking notes about practical applications of four representations for functions. Now let's go ahead and take a look at example A. So here in example A, we've got some words, an equation, a table, and a graph. So we're going to take one of our representations and turn it into all the other representations using the information that we have. The information that we have first is the words, and it says Lena has $2 in her piggy bank. Each week, she adds 50 cents. So we need to turn that into an equation, and we need to turn that into a table, and we need to turn that into a graph. So it doesn't matter which method that we start with. I'm going to start by making the equation. You don't need to start with the equation. You could make a table. It's really up to you. It's going to be hard to make a graph without having the table or having the equation. So you want to start with either the equation or the table. We're going to start with the equation here. So we're trying to figure out the total amount of money in this piggy bank. So I'm going to label that as letter T. You can use whatever variable you'd like. I'm going to use T for total. That's just helpful to me. And we know that's going to equal the amount of money that's in her piggy bank. So right now, she has $2 in her piggy bank, and she's going to add 50 cents each week. We don't know how many weeks that this is going to happen, so that's going to be our other variable, right? We don't know how much is the money total in her bank account or in her piggy bank, and we don't know how much money she's going to have for the number of weeks or how many weeks there are. So in order to figure that out, that's going to be our other variable. But we know to the $2, we're going to add 50 cents, and we're going to add that 50 cents every week. So to show every week, I'm going to have to multiply that, right? If I were going to add it, then that would just be for 1 week. But since I'm going to be doing it for many weeks, I'm going to be using multiplication. So now that I've done that, I've got my table down there below that says X and Y. So we have to figure out which one is our X and which one is our Y. So we have to figure out what thing we're inputting and which thing we're going to be outputting. So in this case, the thing that we're going to be inputting is the number of weeks. So that's going to be our W. So that's going to be our X. That's our input. The number of weeks is going to affect the total amount of money in the piggy bank, not the other way around. So our Y is going to be our total. That's going to be how much money we have in our piggy bank. So let's start by putting out the number of weeks. And we can pick any number that we want to put in our table. But if we're looking over at our graph, we can see that we have the number of weeks as labeled 1 through 6. So if we pick numbers that are above 6, they're not going to be on our graph. So we want to make sure that we pick numbers that are going to be on our graph. So I'm going to pick 0 weeks, 1 week, 2 weeks, and 3 weeks. Again, you can pick any numbers that you want, but again, you probably want to make sure that they show up on the graph. So in order to figure out, we need to figure out the total, we need to take those x's and we can either substitute them into our equation like this. You can see there that I've plugged the 0 in for the number of weeks. So then I would do 50 cents times 0, which is going to be 0, and then add 2, so that my amount is going to be $2 for the first week. Now I could do the same thing for week 1. So again, if I were to substitute it in, I'd do 50 cents times 1, which is going to be 50 cents, plus 2, so I'm going to get 250. And I could start to see a pattern emerge that every week I'm going to be adding 50 cents. So I can continue to substitute, or I could just add 50 cents for every week. So I know there's going to be $3 here, and I know it'll be $3.50 here. So now that I've got all of my points, I'm going to just put them on my graph. So 0 is going to be at 2, 1 is going to be at $2.50, 2 is going to be at $3, okay, and 3 is going to be at $3.50. So I put all of the points on the graph. So I've made all of my representations. I've made an equation, I've made a table, and I made a graph just by making my words. Now my question is, should I connect these points with a line? So if I connect these points with a line, that would mean that the numbers that are in between the points that I already have also work out. But that's not the case, because between weeks 0 and 1, she's not putting any money in her piggy bank. She's putting it in one time at the end of the week. So we can only have one dot there. It's not like she's adding pennies every single day getting up to the 50 cents. She's putting a direct 50 cents in at the end of every week. So we are not going to connect these points, because the points in the middle are not true to the practical words that we have there. Now let's take a look at example B. So here at example B, we've been given the equation f equals 20 minus 4d. We don't have the words, we don't have the table, but we do have some information about what's going on here that we can use to create our words from our graph. We can see that the title of the graph is Raina's Fish Tank. So we know we're going to be talking about a fish tank. On the one side of the graph, we have the number of fish. So we know that's going to be our y, because we can see that up there. And on the bottom, we have numbers of days passed. So we know that's going to be our x. So we can use this information to help us create a word scenario. So we know that as numbers of days are passing, something's happening to the number of fish. So let's take a look at our equation. So f is going to be the number of fish, so the total number of fish, okay, is equal to 20. So it looks like in our fish tank, there are going to be 20 fish. Then minus, no. No. So the equation is minus 4, and d is going to be the number of days. So in our equation here, oh no, what our scenario looks like to be saying is Raina has 20 fish in her fish tank, but each day she removes 4 fish. So it seems like maybe she's either selling these fish or, well, I'll let you decide what might also be happening to this fish on those days. All right, so now that we have that information, let's create a table. And again, we're going to create a table knowing that our x is going to be the number of days passed, so that's going to be our d. Or we're going to have our y, which is going to be our f, the number of fish. We can pick any x's that we want to plug in, but again, let's take a look at our graph, and it stops at 8 days, so we probably don't want to go past that. So I'm going to pick 0, always an excellent number to start with, and then 1, and then 4, and then I'll pick 6. Again, I could have picked any number that I wanted, but I probably want to pick numbers that are going to show up on my graph. So now I'm going to substitute in, like I've done before, that looks like this. And you can see that I've got my 0 substituted in there with my 4. So now we're going to run our order of operations. So we're going to do 4 times 0, which is going to be 0. 20 minus 0 is 20. So on the first day, there are 20 fish. Now I'm going to do the same thing with 1. So 4 times 1 is 4. 20 minus 4 is 16. Then we're going to start removing some fish at a much faster pace. 4 times 4 is going to be 16. 20 minus 16 is going to be 4. Now the last number that I picked there is 6. But if I do 6 times 4, I'm going to get 24. And then if I do 20 minus 24, I end up with negative 4 fish. So unfortunately, I can't use that answer because it's not going to be on my graph, right? There's no such thing as negative 4 fish. When the tank runs out of fish, it has no more fish. So I can't actually plot that point on my graph. So this is another important lesson, that when you pick points that may not work on your graph, in order to get a point that works on your graph, you might have to pick a different x. So since 6 does not work on my graph, I'm going to pick a different number. I'm going to pick 2. 4 times 2 is 8, and 20 minus 8 is 12. So again, you want to make sure that you're picking numbers that will work on your graph. Now that I've done that, we're going to go ahead and put the numbers on our graph. So 0 is going to be at 20, 1 is going to be at 16, 4 is going to be at 4, and 2 is going to be at 12. So again, I've made a straight line, but again, let's check, am I going to draw a line between these? And the answer is no, because she's not taking fish out throughout the time period each day, right? She's not coming back at 1 hour and 2 hours or 3 hours. She's taking 4 fish all at the same time. So we're not going to be connecting these points because, again, the amounts in between the points do not satisfy this word practical situation. Now let's move on to the last example. Here we are at our final example, and it's talking about, well, we don't know. We don't have any words, we don't have an equation, and we don't have a table. The only thing we have is a filled out graph. But good news for us, we know that this graph is going to be about the cost of Ben's bowling. It says right here, cost of Ben's bowling. And we do know our x and y. The x along the x-axis here is going to be the number of games played, and we know our y is going to be the total cost. Again, if you only have the graph, it's very important that you read the title and the subtitles so that you know what things you're talking about. They gave us x and y. That's super valuable information. They've already filled out the graph for us, so with those points, we can just plug them into our table. So we know our first point's going to be at 0, 3. Our second point appears to be at 1, 7. Our next point appears to be at 2, 10. And our point after that appears to be at 3, 13. So again, we've already got 2 formats already filled in. We filled in our table, and our graph is filled in for us. So now we need to make words and equations. So I could make the equations, or I could make the words. I think I'm going to try and figure out the words first because that might help me write my equation. So I'm going to look for a pattern that's happening between each of my numbers here. So I can see that when 0 games have been played, that they're still going to cost Ben $3. So my question is, what would that $3 be for? Well, for one, it wouldn't be $3 because that's not the number on the graph. It should be 4. So let's go ahead and fix that. That will help us better understand that. All right. So now, what is the $4 going to cost? Well, when we go bowling, it could be a $4 entrance fee, but more likely, when you go bowling, you need to rent shoes. So I'm going to think that the $4 there is for the shoe rental. Whenever you're writing the word problems based on what you see, you can of course say that it's $4 for him to enter the bowling alley. That would be fine as long as it makes sense. It can't be $4 for getting a parachute to go off an airplane. That would make no sense in our graph. But as long as it makes sense, you can use that. So $4 for bowling, and then let's see how much it costs per game. So how do I get from 4 to 7? That's adding 3. How do I get from 7 to 10? That's adding 3. How do I get from 10 to 13? That's adding 3. So each one of my games is now going to cost me $3. So to sum up what's happening here, it costs Ben $4 to rent shoes and $3 per game to go bowling. So now that I have that information, I can make my equation, and I can either use y, x, total, or g for games played. So I'm going to use y and x here. So y is going to be our total, and he's going to cost him $4 for the shoes, plus $3 every time that he plays a game. So now I've got my words, my equation, my graph, and my table. That brings us to the end of this set of notes and the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one. Machine in motion.